Today, we're going to talk about an invisible force. But we don't need this book for that. Wait, what just happened? When I pushed the book, it started moving and it stopped on its own. Let's watch again. Of course, the book cannot stop on its own. A force is needed to stop a moving body, right? Well, then who applied the force to stop this book? Look closely. Nothing is touching this book except the surface of the table. So the surface must have applied the force. Also, since the book stopped moving, we can say that the force is opposing the motion of the book. What if I had pushed the book in this direction or this direction? It always stops, which means that no matter what the direction of motion is, the surface will always exert a force opposite to the direction of motion. This opposing force that the surface applies on the book is called frictional force. Looks like friction doesn't want anything to move at all. And that's correct. Friction is exerted by the surface to oppose sliding or slipping between any surfaces in contact. But why does this happen at all? Let's go very close to the surface. Even though the surface was looking very smooth from far away, on the micro level it has peaks and valleys. And because of these peaks and valleys, when two surfaces come in contact, they interlock with each other. This prevents one surface from smoothly sliding over the other. Great! I hope you understood the cause of friction. Now I have a small question for you. Do you think if we take a very smooth surface, then we can completely get rid of friction? The answer is no. No matter how smooth the surface looks from far away, there are always peaks and valleys on the microscopic level. So we can never have zero friction surfaces. But for smooth surfaces, the value of friction is less. So we can say that friction is present everywhere. The bike stops when we apply the brakes because friction acts opposite to the direction of motion of the wheels. Friction not only acts on moving bodies but also on stationary bodies. Consider a heavy cupboard. When we apply force on it, why does it not move? That is because when we apply force on the cupboard, the friction between the cupboard and the floor is balancing our force, and so the cupboard does not move. So we can say that friction also opposes the tendency of motion. Even the bottle I am holding stays in my hand because of, yes, friction. So far we have seen that friction opposes motion or the tendency of motion. But this is not it. There are other effects as well. For example, friction can also produce heat. You can try this yourself. Rub your palms against each other. You will feel that they become warm. This happens because the friction between your hands produces heat. In ancient times, people used friction between stones to generate fire. And there are more effects of friction. It causes wear and tear in your shoe soles or in the tires of vehicles. That's all for today. Let's recap what we have learned so far. We learned that friction is a force that opposes the relative slip between two surfaces in contact. And then we saw that friction is caused due to the interlocking of peaks and valleys present on the surfaces. We also saw that friction always acts opposite to the direction of motion or applied force. Then we saw some effects of friction. Friction opposes motion or the tendency of motion. Friction can produce heat. And friction also causes wear and tear. I hope you enjoyed learning about friction. We will explore more about it later. See you soon.